Hi everyone, how's it going? I'm Professor Peter. Today, I'm going to talk about a robot. This robot made trouble. In a recent chess event in Russia, a boy was playing chess with this robot. In the middle of game, the robot pushed the boy's finger, and the people tried to take him away from the robot, but it took a few seconds. He could take his finger out, but unfortunately, the doctor found the boy's finger broken. Why does this happen? Okay, first, let's talk about this robot. We can find this chess robot in a couple of videos. I think this is quite a famous robot in the chess community. As you can see there, the robot has the developer's name on it. The developer was a chess player, and his daughter is currently a world-class chess champion. In the various events, the robot played chess with people with no problem. In this video, we can learn how the robot moves the chess pieces. Now, the robot will take the opponent's pawn using its knight there. To do that, the robot takes the pawn away first and then move the knight in that location. Here is the problem. In this video, there was nothing below the knight's location. What if we have a chess piece or our finger there? Can the robot notice that there is something below? In the simple robot control, the robot usually moves by following a path planned by software. If the robot hand cannot move down as much as planned, the motors of the robot keep pushing, so the robot hand reaches the target position, no matter what is under the robot hand. That is what really happened in the accident. Let me explain more details. The robot will take the boy's queen with its queen there. To do it, the robot will remove the boy's queen first. However, before the robot brings the queen to the location, the boy rushed and brought his rook to that position. I think that the boy had a tactic that he will take the robot's queen after the robot takes his queen. Unfortunately, he took an action too early. As you can see, when the robot brought its queen to the location, the boy's rook and finger were already in that position. The robot pushed its queen down without knowing what was happening, and the boy got injured. This accident is quite ridiculous. There are a couple of problems we should think about. 1. Should they use an industrial robot? In mass production or automated production, we use industrial robots. Fast, strong. A similar type of robot was used in the chess event. The big difference in these applications is that the robot is very close to human users. Even though the robot will move as planned, there is a small chance that it may move in an unexpected way. This may happen especially when the environment changes unexpectedly. In the accident, the boy changed the environment. The robot didn't know that there was something under the chess piece that it was handling. The robot couldn't handle the unexpected situation. When the robot and humans are working together with the possibility of physical contact, we consider a different type of robot called collaboration robots. It is one of the very active research areas in robotics. The collaboration robots are equipped with more sensors and specialized software that detected physical contact with human users. You may be able to use industrial robots in human-robot collaboration if you like, but to do it, you need to design the system so that it can handle the safety issues. In this example, the robot can detect the human worker's hand, so it doesn't crush the worker's hand. The worker can move the robot arm by simply pushing it, like this. Conventional industrial robot arms don't operate like this. Another solution is soft robots. This is also a very hot topic in robotics. This soft robot hand, powered by pressured air, can pick up an object without breaking it. If this had been used in the chess robot, we could have avoided the accident. Second issue, emergency stop button cannot solve the problem. On most mechanical and electrical systems that have a safety concern, we can find an emergency stop button like this. If you push this button, the machine stops to operate. Even in the chess event, there was the button. Conventional robot arms have a teach pendant. Using this, you can directly control the robot. In the accident, these people tried to use it to stop the robot. I think they pushed the stop button as well. However, it didn't solve the problem right away. Most mechanical systems, including robots powered by motors, have gearboxes. Motor usually generate low torque rotation with high speed, but we need high torque in the robot joints. To solve this problem, we use gearboxes. The gearbox has input and output shafts. On the input shaft, we connect the motor. Then, we can achieve high torque rotation from the output shaft with low speed. The problem is that usually the flow of power is one way. To understand this, let's consider a simple gear system which can be found in a guitar. This small gear is called a worm, and the other is a worm wheel. If you rotate the worm very fast, then the worm wheel rotates just a little bit. Even though the speed is reduced much, the torque is amplified a lot. That's why we can apply high tension force on the guitar strings by easily rotating the tuning knobs. An interesting point is that this gear rotation doesn't work reversely. In other words, even if you try to rotate the worm wheel directly, it cannot rotate the worm because of the friction. The same thing happens in the gearbox. Even if you apply the torque on the output shaft directly, the gearbox doesn't move. This means that when robots are stopped, the robot joints are locked and you cannot make it move by pushing or pulling the robot body. You can see that the robot joints didn't move when the people tried to make the boy free. Third issue, children. What do you do if some children are playing around the construction site? You will tell them to stay away because it's dangerous, won't you? We adults are supposed to be more careful on planning kids' events. The events organizers and the robot developer should have thought about all types of scenarios to prevent dangerous accidents. More and more robots will be popular as the robotic technology is developed. As long as they are mechanical systems, the safety issue should be one of the top considerations in the robot development. That's all for today. Thank you for watching. See you next time. Bye-bye.